Hi guys, hello. Welcome to my channel BST African Electronic Surgery on a Thursday 18 May 2023. And we have some kind of jobs like usual. This is coming from another computer shop, and they just bring the motherboard here for repair. So we have to fix this motherboard if you can. Obvious job from another computer shop or a repair shop, you can't trust. Maybe they've done something, but I can't see like flags or things like that. The board looks clean, so this board has to be fixed. Okay, let's try to fix this one. It's written here, motherboard no power, HP ProBook 650 G2. That's the model of this motherboard. It's for HP ProBook 650 G2 motherboard. So let's see how far we can go with the diagnosis to fix this motherboard. Okay, so what is here? It's a motherboard, and let's start by identifying things. What do we have here? We have fan and very long heat sink, and it's going to the processor. Yeah, that's the processor. This kind of processor is like all-in-one processor soldered on the motherboard. We do have the processor, we have the PCH, we do have graphics all in one here. That's the network cards, SSD 256 gigabytes SSD drive, and here we have the socket for HDD. So it's like an all-in-one. You can send the HDD and the SSD. That's classic, you know. And here we do have the RAM, DDR4 4 gig RAM, we have some cores for the power supplies, and on the other side we have many components, and here that's the Novatone. Okay, and where is my BIOS chip? We do have a BIOS chip here, and just next to the USB ports. Okay, and where is the charging port? Here, you know, this customer is smart. You know that we shall need a switch, and they bring the switch. That's the switch, and here this looks like a small pin charging port for the blue pin HP. That's the charging port, and next to the charging port we have the two MOSFETs connected in serial mode and the current sensor. Maybe you can see here, that's the first MOSFET, second MOSFET, and the current sensor, this black resistor. So Let me look for the charger. So step number 1, you know, if you are in repairs, there are steps which you have to follow to fix a motherboard. You don't just go random checking things. You have to follow certain steps. And the first step will go on the beginner side, because probably this could be another lesson for motherboards repair. So the first step is to check the charger. We do have this charger, the blue pin. The charger is ours, it's not customer's charger. So 100% our charger is working. You can see on the screen 19.37. So our charger is good. Second step, we plug in the charger and we try to check for the main power rail, which is 19 volts, from the charging port to the power supplies. So let's check. On the input of the first MOSFET, you will see on the screen 19.35. That's the input of the first MOSFET. Let's jump over the two MOSFETs and check on the current sensor. 19.35. Even on the current sensor, we do have voltage there. So from the current sensor, our voltage is going everywhere. That is the VCC point. We have 3.3 volts power supply, we have 1.5 for the RAM, we have the vehicle processor power supply, we have the graphics, we have the PCH, we have the 3.3 is on, we have many power supply, 5 volts for the USB. So let's go on each and every power supply and check those ceramic capacitor on the input. We must have 19 volts there. Here we can see coil on the input. Those ceramic capacitor, you see 19.35. This is another power supply. You can see this coil. You can see 19.35. Here we have like 1, 2, 3, 4, 5 coils, and each coil represents a power supply. The first power supply, we have 19 volts on the input. The second one, 19.35. Here 19.35. The last one 19.35. So 100% sure we can all conclude that our main 19 volts power rail is present. I think you can agree with me that in this motherboard we don't have problem with the main 19 volts power rail. What is the next step? The next step is to look for the 3.3 volts, because even if the motherboard is off, the 3.3 volts must be on all the time. So let's look for the 3.3 volts. If we turn our motherboard here, we have the Novatone, that's the EC chip, and around the EC chip We have capacitors like ceramic capacitors. One side of the capacitor is connected to 3.3, always on, and the other one is ground. And this 3.3 is coming from the 3.3 volts power supply, actually from the VREC 3. Okay, I explained about this thing. If you didn't see the video, go back on some of the videos where I explain how the 3.3 and 5 volts power supply is working. So this is the Novatone around the chip. Let's check for 3.3. I'm checking on the capacitors. On the capacitors around the chip. I can't see 3.3. Like really? I can't see 3.3. So do we still have 19? Yeah, we still have 19. So on the microcontroller we don't have 3.3. Let's check on the pins of the switch button. 3.39. First pin, second pin, 3.13. Third pin, 2.46. Fourth pin, obvious is ground. So I don't understand why here on the switch button we have 3.3, but on the microcontroller we don't have 3.3. Let's check one more time. Let's check one more time. Because I have to satisfy it. Why here on the switch button we have 3.3, but here on the microcontroller we don't have 3.3. So where this 3.3 is coming from? Because this 3.3 is coming from the startup chip. $3.39. You can see on the microcontroller 3.39. Okay. You can see that the second capacitor 3.39, here 3.39, here 3.39. So maybe my ground was not touching when I checked it for the first time. So we do have 3.3 here. Okay, so if we have 19 volts, we have 3.3. We can conclude that the voltage necessary to turn on the motherboard is present. So what I want to do, let's see which 3.3 is meant to turn on the motherboard. What I'll do, I'll stick the black probe here, and we'll go on those pins. We want to see if the 3.3 is responding to 0. That's very important. First pin, 3.39. Let's press the power on button. I can hear the switch is clicking. but this 3.3 is not going to 0, so that's not our switch on pin. 1 second. Let's go to the second pin. 3.10, pressing the power button. Still 3.09. Another pin, maybe it is this one. Pressing 0, releasing. Why we only have 2.46? This is meant to work with the 3.3, but we only have 3.39. .45, pressing 0, release. 2.46. So now we have to understand something. The pin which is meant to supply power to the switch button, we are only receiving 2.45 instead of 3.3. The voltage is too low. That's a bad indication. That's a very bad sign. Okay. Let's assume that maybe the switch is faulty. Let's come with a tweezer and try to power on this board with a tweezer. Third pin to ground. No. It's not working here. Okay. What I want to do, let's come with the power supply on that pin which is meant to work with the 3.3. Let's start from that point. Power supply, ground on the USB, and plus here. We need 3.26 should be okay. I'll inject 3.3 here and we'll try Okay, so what can be fault here? What can be fault? Any idea? What can be fault? Because even if we fail to fix this, we must have an answer for the feedback, because obvious the owner has to know what is the fault. We can't say the motherboard is fault, no? That sounds unprofessional. We have to, because remember this is coming from another computer shop, already the person is a technician, so we have to give a clear explanation of what is the fault, why this motherboard is not turning on. It's not a matter of saying this motherboard is faulty, that's all. No, it doesn't work like that. Maybe to customer, but this one is another computer shop. The diagnosis has to be very accurate. Okay, so the next step, let's put our multimeter on diode mode. We want to check coils, the resistance of coils to ground. This one, this one, this one. Because we have to know what is the fault here. You see on this coil, we know that the resistance of the processor is, we know that the processor's power supply has got a very low resistance to ground, but we can't have like 0, that's not normal. So on this coil, you can see 0. We have a problem here. Let's check out the coils. $95 ohms here, 88 ohms. So these two coils, we have 98 ohms and 88 ohms. That the resistance of processor is not short. So don't get confused here. You see the coil is beeping to ground. The next step you say, oh, we have a short. This is not a short. Let me clear out these things. This is not a short. This is the resistance of the processor. Because the processor is working with a very low voltage, around 1 point something volts, so it's very normal to have like this coil beeping to ground. But this one, you have like 90 something ohms, the resistance to ground, and this one we have like 0. So this coil, these coils which has 90 something ohms to ground, you can give a conclusion that the vehicle section for the processor power supply, you can see coils, we have the output capacitor, and we have the driver. This is some kind of new model of motherboard where the MOSFETs are inside the driver. Maybe they are on the other side. No, on the other side we don't have anything here. So clearly inside those drivers inside those drivers, we do have 2 MOSFETs there. So why here we have like a 0 resistance to ground? Why? Okay, let's leave this aside. Let's continue. Here we do have the BIOS chip. Pin number 4 of the BIOS chip, remember, is ground, and pin number 8, that the VCC pin, should not be grounded because it's carrying some power there. So pin number, we do have a dot here, that the BIOS chip. Here we do have the dot, that's for pin number 1. Pin number 4 is normal to be grounded. Pin number 8 is also like 0 resistance. That's not normal. So we found 2 abnormal situations here. One, this coil is beeping to ground like 0 resistance. There's a problem there. And this BIOS chip on the last pin is also beeping to ground, which is abnormal. So we can conclude that the VCC pin, the 3.3 volts, which is being supplied okay, let me say it that way. We can conclude that the pin number 8 is receiving 3.3 from this coil, which is beeping to ground. This is the BIOS chip, but I don't think this BIOS chip has anything to do with the Novatone. Was this some kind of new model with the BIOS inside? This EC chip is some kind of EC chip with the BIOS inside. So don't get confused. This BIOS chip is for the PCH, and it's receiving power from the 3.3 volts power supply, not from the VREC 3. Not from the VREC 3. So before we come with some power supply, let's locate the 3.3 volts and 5 volts power supply. I'll plug in the charger. Let's check again some voltages. What do we have here? Five volts, and on this coil 3.3. You see, that's 3.39. So these 2 coils, this one and this one, that's the 3.3 and 5 volts power supply. Again 3.39 here, 5 volts. So the 3.3 and 5 volts power supply is on, is up and running. So the 3.3 which we are getting here is coming from this power supply, from the 3.3 power supply, from the VREC 3. The Novatone chip is getting power. This BIOS chip is getting, maybe it's a 1.8 BIOS chip or a 3.3 BIOS chip, but this BIOS chip is getting power from the 3.3 volts power supply, which is not meant to be on all the time, not that one. So we can conclude that this coil, which has zero resistance to ground, maybe that's the 3.3 volts for the PCH. So what I would do was, we have to know what's going on here. Let's come with 3.3 on the last pin of the BIOS chip. That's the easiest way to see what's going on there. Or we can lower the voltage to 1.8. Since we are not 100% sure that this is the 3.3 volts BIOS chip. 1.78. So 1.79 you can see on the screen. Let's come on the pin number 8, and it's taking 1.6 amps. .6 amps is a lot. It's a lot, and we have to. My first suspect is the PCH. So let's take out the heatsink and feel the temperature. That's the processor. That's the PCH. This one. All in one, and the graphics is also inside the processor. So we have to know something must be warm or getting hot with 1.6 amps. Something has to be warm. What did I told you? What did I told you? I know. This seems like it's unfortunate we can't fix this. .22. And the PCH is getting hot. So let's go under microscope and check together. Let's see now. Let's see under microscope. What do we have here? We have this charging port. Just to recapture what we have explained, we have the charging port here. That's the port. Next to the port, we have this big MOSFET. We have the second MOSFET, a smaller MOSFET. We have this black thing, that's the current sensor. And here, that's the processor. We have the PCH and the processor all in one. So what I would do, like usual, Let's supply some power here and see what is taking power. Let's use alcohol. Let's use alcohol. I'm now supplying power. Hope we are seeing what's going on here. The reason why I'm saying I can't fix this one, I supply power, I release power, that the PCH power supplied is drying quickly, I release, the liquid is coming, I inject, you see, I release, the liquid is coming, I inject, the chip is drying quickly, you can see. We don't have a thermal camera, so we have to use this method until a point when we shall get the thermal camera. See how the chip is drying. So this chip is pushing like 3 amps. You can see those bubbles. Look what the chip is doing. The liquid is running around the chip. So that's the thing. So our PCH is shorted. So unfortunately we can't fix this one. We can't fix this one based on what we are seeing here. If the PCH is shorted, I don't think I can do anything. I don't think I can do anything. I'm not saying it's not fixable. Some they are doing reballing. It's about country. But here in my country, Zimbabwe, usually that's where I stop. Because one, I don't have the BGA reballing machine. Even if I buy it, it's expensive. And if I try to pass the expense to the customer, all of them, they will run away. Because we are not charging too much on repairs based on the model of laptops which are still being used in my country, or devices. I think we are 10-15 years behind technology. We are still using those devices which were dumped long ago by other developed countries. So because of that, cheap machines means the repairing cost or the repair price will be lower. So why should I stress myself buying a BGA machine? So we have a problem. I'm sorry, I couldn't fix this one. This is a challenge to me, but yeah, just spending time for nothing. But you can, to someone, maybe can be helpful to know what you can fix, what you don't, what you can't fix, how to get to the final conclusion that the processors did. Because I see a lot of motherboards or laptops, they come here, they said this processor's dead. At some point I found this is a different issue. I fixed the board, the laptop start working, but for sure here we have a problem with the PCH. So yeah, sometimes you have to spend time just to spend time trying to fix, and I'm sure everyone who is in this repair business, you are getting such kind of things whereby you try to fix something, you spend hours after, at the end nothing came out. So I'm now used to this, but at first I was getting very much angry when I can't fix something. You can't fix everything, even the doctor. The patients, they go to hospital for various sicknesses. Some they get treated, some they die. Same here. This is another time. This is the right time for another laptop, or we order another motherboard for the client. So like, subscribe, don't forget to turn on the notification bell. Remember to share our videos, our links to your friends and relatives. See you on the next one. Bye.